are going to be talking about artificial intelligence for about 20 minutes. Who of you think you know what artificial intelligence is? Sort of? Has anyone seen like Terminator or Her or Ex Machina or any of these movies? It's not quite what we're going to be talking about today. But artificial intelligence is one of these technologies that has gotten a lot of attention lately. Everyone is talking about it. Every speaker that you're going to hear here today is going to mention it somehow, right? Artificial intelligence, like in the applied sense, as in what we're actually using today, is already in your phones. It's already on your laptops, etc. It's a technology that is going to be everywhere. And the reason for this, so the technology, the research behind artificial intelligence and machine learning, which is another term we're using, the research is really old, right? Already in 1956, we were talking about artificial intelligence, or this idea to have a machine that could be as smart like a human being can and learn. But we were really limited. We were limited by access to computational power, as in servers, as in computers, and we were limited by access to data. So if you go back to when, pretty much when I was your age, maybe 5-10 years before that, in order to do anything with this artificial intelligence technology, you had to be a professor working at a university with access to like one of those supercomputers that Tiffany was showing you earlier, like a room full of one computer, in order to do anything with AI. But in about 2012, so about 6-7 years ago, two things happened, right? So one is that thanks to the internet, we have so much data available, right? Think of all the data we produce, through whether it's Facebook or Snapchat or posting images, blogs, like all of this information is readily available. Secondly, we suddenly had access to computational power, right? So you can go on Amazon or Azure or any of these services and say, hey, I need a server, I need a machine that can run all of these algorithms, and boom, it's there, right? Which means 2 kids in a garage can build something now that 20-25 years ago you had to be a professor to do. So that's what's happened in the last just, 7-10 years, is suddenly all of that was accessible to us, which means any one of you can sit down at your laptop and do something that 20 years ago you had to be a professor to do. I think that's pretty cool. When we talk about artificial intelligence, there's kind of 3 levels we operate with, or 3 kind of future levels, if we want. The first one, or the top one, is artificial superintelligence. The idea is that one machine is as smart as all human beings on Earth combined. We don't know what will happen when if we have, one machine that is as smart as all human beings on Earth together. That is when we kind of get into like the Ex Machina, the Terminator movies, all of that. Like, I have no idea, you have no idea, no one knows what will happen. The world will look very different. We are not there yet. Will you see this in your lifetime? Maybe. Maybe, depends on how long you live, which is, Tiffany's job, to extend our lifetimes. So that is, but it's far away, right? So we don't have to worry about Terminator just yet. Then we have artificial general intelligence, which is this idea that one machine can be as smart as one human being. Right, so if any of you have called like a bank or an insurance company, you get this like automated voicemail, right? And it asks you to speak and say what you want, and you say it and it understands it and it reroutes you and it gets you to the right person, right? Which is an AI technology. It recognizes your voice, matches that to the different things that you can do on this service and sends you there. Now, if I call that, phone and I'm like, hey, how do I make like pita bread? It's not going to know because it's not trained for that. And that is what we call artificial narrow intelligence. One thing and one thing only, right? So artificial general intelligence should be able to learn how to pick up a phone, how to order tickets, how to bake pita, like all of those things. But narrow intelligence, which is what we have accessible to us today, it does one thing and one thing only. It can do that thing way better than humans, as Tiffany said about the doctors, right? And diagnostic of cancer, for example. but it can't do much more. The cancer doctor that is specifically trained for birthmarks to see those, it cannot also do lung x-rays, for example, right? It can do one thing, it's trained on one thing, and if you wanted to also scan x-rays of your lungs to look for cancer there, you have to retrain the system entirely. So we're talking about very narrow intelligence, and when we talk about the general intelligence, the human level intelligence, we're still quite far away from that. Sometimes you'll read in the newspapers that it's happening right now, but it's not, right? We're talking 20, 30, 40 years into the future. Now, the systems of today are going to be really smart, but the whole kind of general, human-like robot or AI that can learn anything and understand anything, have a full conversation about any topic, that is still far into the future. So I say artificial intelligence, and it's a very big term, right? We're both talking kind of Terminator and kind of Ex Machina, all of that, and we're also talking like a stupid little chat bot that can find you the right person today, right? It's a very big span of what we're talking about. Artificial intelligence per 2019 is fairly synonymous with machine learning, right? So you usually hear the two terms used, AI/ML, is what usually people talk about. Which is more or less the same as neural networks, which is what Tiffany mentioned in the diagnostics tool as well for the medical purposes, which is fairly synonymous today with deep learning. So when I said that the access to computer power and access to data has enabled this kind of revolution that is happening right now, deep learning is the technology in that, right? Now, if we want to get to a general intelligence, deep learning isn't going to be enough. Deep learning is great for doing recognition in images. Deep learning is great for a number of things, but not to build general intelligence. And as I mentioned already, this is really old technology, right? Neural networks, 1958. Deep learning, 1986. It's a long time ago. I was born in 1985. I'm starting to feel old. This is a long time ago. So one of the ways we usually talk about artificial intelligence, it's a really bad way to talk about it, but it makes it easy to understand, is that regular software, right? So when you open, any app on your phone, it's a regular piece of software, right? And you expect it to do the same thing every time. So it works much like a calculator. If you open Snapchat and click on a filter, you know what to expect. You'll get the same result every time. Not so with machine learning. What we usually say is that it's shaped after the human brain as it can learn, right? So I'm standing here today, I'm observing you while I talk, and I learn from that, right? And I can improve my talk the next time because I see your reactions. I'm like, oh, I tried making a joke, no one laughed. Okay, I'm gonna make a better joke next time. So I'm learning. Machines, my Snapchat filter isn't necessarily learning. Actually, Snapchat filters are a bad example because it is based on machine learning. It does learn. Any other app that isn't as smart as that. Those machines, like the machine learning applications, they learn over time, right? Much like a human brain. So the more data it sees, the more images it sees, etc., the better result it will get over time. However, this is wrong for a couple of reasons. First of all, we don't understand how the human brain works. So saying that we build machines that work like the human brain is wrong, because we don't know how the human brain works. Secondly, we don't want to build machines that work exactly like the human brain, because the human brain is incredibly limited. As beautiful as it is limited, right? So did you know that when you remember something, it's only 20 to 30% of your memory that is actually stored in your brain. And then everything else you remember, that you think you remember, your brain kind of just recreates. It remembers the most important stuff, and then it just recreates the rest. And there's this really interesting study, it's called The Lady in the Red Dress. And it's this group of people who every year they were brought together and they were asked about a specific event they'd been to, a specific vacation or something. And every year they were asked, do you remember the lady in the red dress? And the first couple of years, the people were like, what lady in what red dress, I can't remember. But after having gotten the question obviously there was no lady in a red dress anywhere, but after like 2 or 3 or 4 years, as they kept getting the question, like, do you remember the woman, the one in the red dress? At some point, they all started saying yes. Because they'd heard it so many times, their brain was like, clearly it's something I've forgotten. And they all remembered, like they had this visual image of a woman in a red dress that was part of that vacation. We don't want to build machines that work like the human brain. We want to build machines that are complementary to the human brain, that can help us remember whether or not there was a woman in a red dress there, right? We want to help build systems that can work with us. One of the reasons historically, when we've dealt with artificial intelligence, and one of the reasons why we're seeing these major breakthroughs right now is that recognizing that a cat is a cat is very difficult for a machine, right? Now, if a 2-year-old child, sees a cat, how many cats does a kid need to see to recognize that that's a meow? I don't know if you say that in Greek. That's what they say in Norwegian, right? Meow. How many cats? Like maybe 5 cats? Maybe a kid needs to see 10 if the kid is a little slow, right? But then they know, like that's a cat. It's easy. It's like something we do intuitively. No one needs to tell us what a cat is, right? We see it, someone says it's a meow, we see 5 of them, we're like, okay, that's a cat, that's a dog, that's a guinea pig, fine. However, up until 2012, up until, the deep learning revolution, in order to make a machine understand what a cat is, we tried to build what was called expert systems. It was still under the umbrella of artificial intelligence, but what we did was that we gave it rules. We gave it a lot of rules, right? And if you want to build the rules of like what is a cat, you're like, well, okay, it's got pointy ears, it's got a cute little nose, it's like fluffy, unless it's one of those naked cats that doesn't have fur. All right, and those are rules. And then it's like, well, that also sounds like a guinea pig, right? Well, the cats are slimmer, unless it's pregnant, right? And you start building these rules, it becomes incredibly complex to try to like differentiate cats from other animals. They've got 4 legs, a tail, like how do you describe it? But we humans just know it, right? So until 2012, these were kind of the expert systems that were built, and they didn't work well. Machines were terrible at recognizing that cats were cats. However, with deep learning, per about 2 years ago, human beings make errors 5% of the time in doing things like recognizing that a cat is a cat. 5% errors, which is a little baffling to me, but 5%. Machines were 2 years ago at 3.6% errors. So today, machines are better than us at recognizing that a cat is a cat. And that is one of the reasons, or the main reason, why we're seeing all of these applications like the cancer, right? This is the technology behind that, deep learning and image recognition. And this is not just images, right? We're seeing these breakthroughs in text as well, and a number of other fields. And I want to give you one example of how fast this has gone. I'm going to assume that most of you have not printed physical albums, right? Physical photo albums. This is from 2006. Have anyone seen like their parents' photo albums and gone through like old photos? So you'll know that, right? This is the last physical album I ever printed. I was on vacation in Corfu, and it was 2006. That's 13 years ago. There's several things that have happened since 2006 when I printed those albums. First of all, this is a camera with like physical film in it, right? First thing that happened was that the digital cameras that didn't have film got cheap enough so that I, as a 20-something-year-old student, could afford it. I was 21 at the time. I could finally afford a digital camera. Great, so I got rid of the old one with film and got a digital camera. A few years passed, the iPhone came on the market and got cheap enough, well, maybe not cheap enough, I made more money, I could actually afford an iPhone, right? So I replaced my digital camera with an iPhone that had a really neat camera. Then came like iCloud that allowed me to store more than just like 10 images on my phone, and a number of things like that. And then in 2016, so 10 years later, right, 10 short years later, going from a physically printed album to telling my iPhone, I want to see any picture ever taken of a Christmas tree, any picture taken of a skyscraper, any picture, of course, taken of a cat, right? And this is technology that, again, if you wanted to do this back in like pre-2006, 2000, you had to be a professor and with a supercomputer. And like in 2016, sure, I'll just run it on my phone, not a problem. Another example of how fast things are going is this. And you might have seen a couple of these videos, but I want to show you two videos, one from 2014, one from 2018. So we're talking 4 years difference of these two videos. This is Siri, Apple's Siri in 2014. And there is audio on the video, so I'm hoping that will play.
Switch off iPhone.
Change what?
Turn off the phone.
Which setting?
The power setting.
I don't know what you mean by the power setting. Turn off what?
Phone.
Call who?
No one.
Okay.
Okay. Understanding context in a human conversation can be really difficult, right? Phone. What do we mean with phone? Are we talking about a phone, phone someone? Contextual understanding is really hard. But then 4 years passed, and this is not to compare Google to Apple, because they're both developing really well. But this is 2018, and some of you might have seen this video. But we'll play it again. The robot is to the left.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually we reserve for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
So, of course, keep in mind that this is a marketing video, and a lot of the marketing videos you see are going to be exaggerating a little bit. They probably have 10,000 hours of recording, and they pick the best one. It's also incredible how human something sounds when you add some sprinkle that across, and suddenly the robot or the AI sounds very human. However, the contextual understanding, right, the ability to hold a flowing conversation and understand what we're talking about, has radically improved in 4 years. Now, where are we going to be 4 years from now, 8 years from now, 16 years from now, as we double this, right? At some point very soon, you're not going to be able to hear the difference between a human and a robot. Which raises some really tricky questions, right? That and everything else. And I'm not going to spend a lot of time on these questions, but I think it's important that to keep this in mind as you move forward into the future. Now, a question I often get is, are you building Skynet? Because I run an AI company. And that's like the evil by intent, right? Evil by, where we're going to build a system and it's going to take over the world. In Terminator, it was slightly different. But, it's this like idea that we'll build a system and it will be evil and we'll take over the world and it will tear down all humans. And I'm not very worried about that. There are scenarios where that could happen, where kind of bad people take over these systems. However, I am much more concerned about that. Evil by, we didn't think that far, did we? And we've already seen this, right, with Facebook starting out as like, which girl in your class is hotter or not? Like, that was the starting point of Facebook. Like, how could Mark Zuckerberg predict that, like, 10 years later, he would be responsible for that is American politics right now, right? Which is like, literally, Facebook is one of the main kind of responsible for that and for kind of political advertising. How do you predict that? How do you think that far? It is incredibly difficult. The brain, as I talked about earlier, is limited, right, with a lady in the red dress and all of that. We have so many biases, right? We know what we know, and it's easy to think that that is the truth. That is never the truth. A couple of quick examples. Face app have anyone used Face app? Do you know it? Yeah? So they had an example a few years ago. I don't know if you saw that, but they added a filter that was called hot. Did anyone want to try that? It was a filter that was called hot. And that worked great. You know, old, young, whatever, hot, it made you prettier. It was great, unless you looked like Terrence. When he applied the hot filter, his skin was whiter and his nose was narrower, right? Applying very European and American beauty standards, right? Now, here's what happened. I assume there was a room full of white men in their mid-20s, because that's what a lot of machine learning engineers are, and they go, hey, let's make a hot filter. Someone goes, great, we need a database of images of people that are really hot, right? Makes sense. Someone goes, oh, I know about this database of models, male and female, it's gonna be great, let's use that. They fetch that database, they do the training of this neural network, they pull up their phone, try it, and they're like, yeah, I look hotter, great, perfect. Okay, let's push it out to all the users. And no one in that room stops to ask themselves, just, does everyone look like me? Like, it's a very, very basic question. But when you have a room full of people where everyone has the same lived experience, everyone thinks in the same way, no matter, I mean, it just happened to be a lot of young white men doing this, but it doesn't matter if it had been a room full of older black women, you know, we'd had other problems, similar problems, right? But when one room full of people who all think and act and have the same lived experience, we run into these issues, right? It's an unfortunate side effect caused by the training set bias, i.e., we picked a collection of only white people for these pictures. A similar thing, though slightly different, is Google's job search algorithm show kind of top-level, like boss jobs to men 1,800 times and women 300 times, right? The reason for that is that historically speaking, men are the ones that have been bosses. So when you base the future, right, because the people who see the job ads are the one that's going to respond to the job ads that are the one that are going to get the job, and if you project the future with historical data, you're going to repeat the same mistakes that were done before. So how do we avoid that? Also, I want to wrap up with this. Don't give weapons to autonomous systems. Do not give weapons to robots and tell them that they can make the kill decision. And don't be naive in this. Our governments are already building these systems. It's a terrible idea and we shouldn't do it, and our governments are. Very briefly, I'm going to just rush through a bunch of examples of things that are going to be really cool in the future, thanks to AI. The other speakers today, other kind of areas you're going to look at over the next few months and years, they will all be affected by AI. Here is some of the things that makes me really excited. Autonomous systems, autonomous vehicles, autonomous motorcycles, I'm kind of excited for that at some point, right? All of these technologies that are going to be autonomous, machines that are going to operate themselves in traffic and all around us. Chatbots today, let's face it, chatbots today suck, right? They're terrible, they're annoying, but they're the worst they're ever going to be. And you saw the Google and Apple example, they're going to get radically better very soon. Maybe at some point, or they will at some point in the future, give you personalized advice, whether it's about your mental health, your finances, anything like that. Our homes are going to get smarter with smart thermostats, etc. I'm excited for a future where every child that enters into school will have an AI tutor that knows what they've learned, how they learned it, how they can be their best possible selves, and correlate that back to the teacher, the human teacher, to get the best possible help. And why stop at children, right? Grown-ups also need a little help now and then to get out and exercise, go spend time with friends, not just sit in front of the TV, to be our best possible selves. Outbreak prediction for diseases, whether it's Zika or malaria, etc. Healthcare is going to be more and more autonomous, as in there's going to be less and less need for doctors, as Tiffany has already said. There'll be other and changed jobs for doctors. We're still going to need those people with the expertise, but it will radically change. So at the end of the day, we're facing a world that is changing really, really fast. And in order to avoid some of the biases, some of the problems that I mentioned, we have to bring that empathy that Tiffany also talked about. I'm repeating her a lot because it's important, right? You have to bring empathy into it. If you're not a white male, you have to take a place at the table, right? You also have a responsibility to put your foot in and say, hey, I want to be part of this, right? We need more women, more people of color, more people with disabilities into this game as well. And with that, I am a little bit over time, so I'm going to stop talking. If you have any questions, feel free to get in touch. And thank you so much. Enjoy the rest of your day.